Hello.
Hello.
Hello. Actually, there are so many background noise.
Yes, sir, but I'm in the room right now, so I can't do anything.
Okay, fine.
Yeah. Is it possible to hear me?
Yeah, I can hear you properly. Actually, there is some noise. Actually, that's it.
Uh, that's okay.
Oh.
Can we discuss the questions which I have sent?
Yeah, I will. I'm opening those things only.
Okay, thank you. The graphical method and analytical method.
Yes. Okay, is it visible?
Yes.
Okay, so these questions he sent me these 5 questions, and then
This
the
task.
trust problem. So okay, we'll start with this task first. Then
Okay.
okay. So actually, trust problem you can solve using 3 methods. One is the graphical, and another that is uh, type of analytical, like the method of joint and method of friction. Okay.
Okay.
So first of all, if we try with graphical one, now obviously the graphical we can't do now properly, because for that we need scaling. But at least we can discuss the method.
Okay.
Okay.
Yeah.
So okay, fine. So if we draw this one, oh, it's a drawing. Okay, fine. Then another line here. Okay, and then we have this join. Okay, fine. Now, if we do push the loading, that is 2 kilonewton, 3 kilonewton here, and 1 kilonewton here. So here it is 2 kilonewton. Here it is 3 kilonewton. Here it is 1 kilonewton. Now at this 2 point we have supports.
Okay.
One is pin support and another one is roller support. Okay.
Okay.
Now, so when we are going to draw the 3-boy diagram, so instead of these supports, here it is roller. So here we have only vertical reaction, right?
Yeah.
And at this point we have both vertical and horizontal also.
Horizontal.
But actually, look at the forces. All the forces are vertical. So
Vertical.
that one will be zero at
Okay.
equilibrium.
Okay.
Okay.
Yeah.
So our first step is in graphical method.
Mm.
The graphical method.
Mm.
The first step is we need to find R1 and R2 using equilibrium equation.
Okay.
Equilibrium equation.
Mm.
So equilibrium equation means what?
Is all the vertical forces will be zero and
Yeah.
moment about the point will be zero.
Yeah. So suppose this is our point A, this is our point B. Then at
Mm.
with respect to any point MA or MB, we can write moment is zero.
Zero. Yeah.
So from the
Mm.
summation of vertical forces means
Mm.
R1 and R2 positive.
R1 and R2, 2 and 3 negative,
Also
and
this
1
one.
negative.
So
Yeah.
-6. Fine.
Mm. Yeah.
And now moment at A. Tell me what is the moment at A. Suppose all these lengths are given. English, just chart or a type. Okay, lengths are not given, but actually what we can understand that
Lengths are
this,
1 meter. All members are 1 meter.
okay, all members are given 1 meter.
Yeah.
Okay, fine. So actually,
Mm.
the first step is actually you need to draw this one.
Okay.
Okay, you need to draw this one by proper scaling. So what we can do, that is 1 meter, right?
Uh,
Now in your page, obviously you can't draw 1 meter length line.
yeah.
So we need to do scaling first. So what we can do for this one, 1 meter, we will draw as 1 centimeter.
Okay.
Okay, that we can do.
Okay.
And as all the edges are 1 meter, so these are equilateral triangle.
Mm.
Fine. So
Yeah.
so actually you can draw this one. Just draw this line that is 1 centimeter. Then from these
Mm.
2 points, take 1 meter, 1 centimeter, and using compass you can draw.
Okay.
Or using protector also, just make a 60-degree angle, then
Mm.
at 1 centimeter in
Mm.
this way. Okay.
Yeah. Okay.
Now what will be the moment about point A?
Mm. 2 into 0.5
2 into 0.5.
0.5 plus 1 into 1
Okay,
plus
plus 1 into
3
1.
plus 3 into 1.5
Okay.
minus r into 2 is equal to 0.
Yeah. So if we do that, we'll get R2 as 1, 1, 2 plus 4.5. That is 6.5 by 2. That is 3.25 kilonewton.
Okay.
So if we put here, we'll get R1 as
Mm.
6 minus R2. That means 2.75 kilonewton.
Okay.
Okay. So reactions are
Yeah.
fine. Reaction, uh, not this one here. So reactions you need to find out using
Uh,
equilibrium equation.
equilibrium equations. Yeah.
Okay. So
Yeah.
instead of R1, R2, now we can write our values.
Mm.
So that is R1 is 2.75
Mm.
and R2 is 3.25 kilonewton.
Okay.
Here, no horizontal forces there. Fine. Now look, here they have mentioned these things A, B, C, D, E, F, G, H. Okay.
Mm.
So
Yeah.
we need to do that. So what is the procedure for that? So that is our first step. Now our second
Mm.
step is
Mm.
we need to do the nomenclature
Mm.
between the forces.
Okay.
Okay. So
Yeah.
look here, 2 kilonewton force is applied. Here 3 kilonewton force is applied. Okay.
Mm.
So in between this, we are giving that is our section A. Okay.
Okay. Yeah.
Now first up, we will go outside this truss.
Mm.
Okay. So A
Mm.
done. Now coming to this side. So between three, here we have 3.25. So this
Okay.
area we have to mention. So that is D.
Mm.
Okay.
Mm.
Then between 3.25 and 1, here it will be C. Okay.
Okay. Yeah.
Similarly, between these two, that is D.
Mm.
Okay. Then we have come here. Now, between these two, here it is our E.
Mm.
Okay.
Okay.
So
Okay.
outside force, outside area is covered. Now we
Mm.
come inside. So inside we have
Mm.
total three sections. One,
Mm.
two, three. So we'll
Mm.
give name like this, F, G, H. Okay.
Okay. Yeah.
Okay. So now we need to draw the diagram
Mm.
of force diagram or vector diagram, what we can call. Okay.
Mm. Mm.
So how to draw that? That we need to discuss. Okay.
Okay.
So first of all, we will start with A.
Mm.
Okay.
Mm. Yeah.
So suppose this is our point A. Okay. Before that,
Mm.
what we can do, we can draw a
Mm.
mm, vertical line first of all.
Okay.
Oh, okay. Now, first of all, we will check for the outside points. Okay.
Mm.
So from A, when we're so suppose this is our point A.
Mm.
Okay.
Yeah.
Now from point A to B, here we have 3 kilonewton force downward. Fine.
Mm.
So we'll go. Okay. For the forces also we need to do scaling. So what we can do for 1 kilonewton, we will take as 1 centimeter.
Okay.
Okay. So here 3 kilonewton force downward. So we will move 3 centimeter downward.
Mm.
Okay. So
Okay.
that point will be our B.
Uh,
Okay.
yeah. Okay.
Now from B to C, what is the force? That is 3.25 kilonewton
3.25.
upward.
Mm.
Right. So we need to move upward.
Mm.
And the distance will be 3.25. 1 kilonewton is
Yeah.
1 centimeter. So 3.25 centimeter. Okay.
Okay. Yeah.
Now this is 3 centimeter, we know. So that will be somewhere here.
Mm.
Okay.
Okay.
So that is our point C
C.
that will join. Okay. Now from C to D, look, 1
Mm.
kilonewton downward. So we'll move
Mm.
1 centimeter downward. So that is 0.25. So here another 0.75. So it will be somewhere here. That is our point D. Fine.
Mm. Okay. Yeah.
Now from point D to E, that is 2.75 kilonewton upward.
Upward.
So from point D, we'll move 2.75 centimeter upward. So it will be somewhere here
Mm.
actually. because that is from C to D is 1. So 1
mm,
plus 1.75. So somewhere here we'll get, suppose.
okay, okay,
So when we'll draw this one using scales, we'll get the proper distance here. Okay.
okay,
So that is our E. Now we need to draw F, G, and H also. Fine.
mm, mm,
So how can we get that? The outsider ones are easy. That is
mm,
done.
mm,
So first of all, look at the position of F.
mm,
F is in between E and D here. Okay.
yeah, yeah,
So for that, what you can do, look, D is horizontal line.
mm,
Okay. Also
mm,
C is horizontal line. Also our
okay,
A is horizontal.
yeah,
So we will draw the horizontal lines first of all from those points. So from A, we have one horizontal line. Okay.
why so horizontal? Because A, why did we do horizontal line? Because
Look at the
A is a
position.
horizontal line, that's why.
Yeah.
Okay,
Yeah. Similarly,
mm,
C and D.
okay, fine.
So from C, again draw a horizontal line.
Mm,
Okay, we can change this. Yeah, fine. Similarly, from D
mm,
also.
okay,
Okay, fine.
mm,
Now look at E and B. E is
mm,
at 60-degree angle here.
yeah,
Okay. And it is,
mm,
and what is the position? Means what we can call uh, E is 60-degree here
mm,
from here or from here. Okay.
mm,
So that is
yeah,
our point E.
mm,
So from point E, we will draw a line which is 60-degree.
okay,
Okay. Don't think about the length that we don't know, but
mm,
at least we can draw at one line that is at 60-degree with the negative y-axis.
okay,
Uh, okay, wait. Not 60-degree. This angle is 30-degree, right?
uh,
Total is
yeah,
60, so this one is 30. So this angle will be about 30-degree.
oh, okay,
Fine. Similarly, B. B you can draw. That will be a
mm,
60-degree with a negative x-axis. So
mm,
from B, just draw that line.
mm, mm.
Hmm.
From B,
So
60-degree from B,
actually, what you can do,
uh,
what will be the better understanding? Look at
mm,
position for E. We have
mm,
this line, right?
yeah,
So draw parallel line of this one from E. Okay, so these two should be parallel. This one is not look like parallel.
okay,
Change a little bit more. No, I think it's fine.
okay,
Okay. So E, that line and here this line, this should be parallel and that the starting point will be E. Okay.
mm, mm,
Similarly, for B, this one and this one, these two should be parallel and starting point will be our B. Okay.
that is which line? This
Which one?
from B, from B, which line we drew from B?
This
This
one.
the sec. Okay,
Okay.
okay, yeah,
Uh, okay. For outer, it's fine, right? You can understand that depends on the value of the force, you will go up
mm,
and down on the direct, depends on the direction,
mm,
right? And for
mm,
this one, what we can do, draw parallel line of E
mm,
of trace diagram
mm.
to the vector diagram
Okay.
starting from position position E.
Mm.
Okay.
Yeah. Okay.
Now, actually, we need to find these 3 points, A, G, and H.
Mm,
Now, look at position of A. That is at
mm,
the this section. So that is at the connection of E and D. You can take.
yeah.
Okay. So look,
Mm,
E is coming this way, and from D, this is the line. So
mm.
that point, that is our F.
Okay.
Okay.
Mm,
Similarly, for H, what you can do, B
mm,
and C.
mm.
Actually, look, what you can do, you can take also A and B, but between A and B, there is another line that we don't know, right?
Okay.
But
Yeah.
between B and C, there is nothing. So between B and C, that will be our H. So B is this one, H is this one. So this point, that is our H. Fine.
Okay.
So F and H done. Now we need to find out G. Okay.
Okay.
So for G, what you can do, between F and G, we have this line,
Between H and G. Yeah.
F and G.
F
So
and G.
yeah, so draw
Mm,
parallel line of this one from point G. So this will be something parallel to this one, because this one and this one, these two are parallel, right?
mm,
This one is our B line. So from if we need to draw a parallel line here. Okay.
mm.
Similarly, between G to H, we have this one, right?
Bit.
Between G and H.
Mm,
So we need to draw a parallel line of this one from H.
mm,
So if you draw that, so that means from H, it will be this one. Okay.
mm.
Hmm. Actually, there is a little bit mistake in the drawing. Otherwise, what will happen when we'll draw properly using scaling, you can check
Yeah.
that these two lines are meet on the line of E. That point, that is our point G.
Line of A.
A point, you know, we have
Yeah.
started from point A. So we have drawn a horizontal line also parallel to this one. Okay.
Mm, okay.
So when we'll draw properly using scale, what you can get that this line that is from F and parallel to this one.
Mm,
So, and G and H, in between this, we have this one line. So draw parallel line of this one here from H. So if you draw this one, these two things will meet at the point from where the horizontal line 2A we have drawn earlier. Okay.
mm. Okay.
So actually don't need to think about this line that cross that intersection point between these two lines, that is our G. Okay.
Okay.
So all the points we have, now what we need to find out? the question, we need to find out the uh, forces acting in the pin joint members. Okay.
Mm.
So for that, if we just make a table, so for that we need to nomenclature this thing. So A, B, C, D, and this one suppose E. Okay. So
Mm.
how many members we have? 1, 2, 3, 4, 5, 6, 7. Right?
Mm. Yeah.
So AE, EB. So members are AE, EB, then
Mm.
A2, A, B, C, D, E. So AD, then ED or DE we can call. Then from E to A, wait, then E to C, then C to D. So EC, CB. 1, 2, 3, 4, 5, 6. The last one. Okay, that is CD. Fine.
Mm.
So these are our 7 members. Fine.
Okay.
Okay. Now think about member AE.
Mm.
Of which one? This one, AE. Okay.
Mm. Yeah.
So for AE, what are the two sides? That is D and F.
D and F. Yeah.
For this member, the two sides are D and F, right?
Mm. Yeah.
So here we can write this one as D and F. Fine.
Mm.
So check. So find out the length between these 2 points.
Mm.
Okay. Suppose
Okay.
this length is, suppose that is 3 centimeter. So the
Mm.
force will be, our 1 centimeter is 1 kilonewton. So that will be 3 kilonewton.
Mm.
Fine.
Yeah.
So find that length df. So that is the magnitude of the force.
Mm.
Okay. Now what we will check that it is in compression or tension.
Mm.
Okay.
Okay.
So for that, what we can do, just try to, mm, suppose we are jumping from D to F. Okay.
Mm. Yeah.
So at that point, look at your right side. What will be the right side? That is this side.
Mm.
Fine.
Yeah. Uh, so what was it? I didn't understand.
Mm, look, what is the method actually to check if this member is in
Are in
compression or
compression or
tension?
tension?
So for that, the method is just think that we are jumping from point D to F. So that means
Okay.
we are at position D, we are looking at F. So what is our
Okay.
right side? This one, that is left,
Uh, yeah.
right? So this one is our right side.
Mm.
Fine.
Yeah. Yes.
Now coming to here,
Mm.
so uh, so negative. So from D to F. So that
Mm.
is moving this side,
Yeah.
right? So here the
Yeah.
direction will be this way. Similarly, here it is the opposite. Here it should be the opposite one, as it is a
Mm.
member only, axial member. So if it is this side, so here it is this side. Okay.
Okay.
So what is the method? Uh, Recording, right? So you can check it later also. So for
Mm.
any member, suppose you are checking for this member. So
Mm.
consider consider the 2 points uh, that is at two side of this one. So that is D and F. Fine. So
Mm.
just try to just look in this way that you are at position D, you are looking at F.
So why can't we look from F to D?
That also you can do. Just check if you from F, if you are looking at D. So that means tell
Mm.
me what will be your right side?
F to D.
This side or this side? Means A side or E side? Tell me.
A side.
A side, that is your right side, right?
Okay. Yeah.
Now check here. F to D you are trying to go. That is the direction.
Oh.
So here it will be this direction. Fine.
Okay.
So
Okay.
whatever you are choosing, that from D
Mm.
to F or F to D, you
Mm.
need to check here also in the direction. What is the direction? Also, you need to check and you need to check here and put that direction here at the right side of your jumping.
Okay.
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 So now tell me if this is the force, direction of the force, then the member is in compression or tension.
Oh. Tension.
Yeah, that is in the tension. Similarly, we'll check for another 2 points. Other 4 points you can do by your.
Okay.
Uh, this one we did. Suppose we are doing for this one, and then we'll check for on inner side. Suppose for this one, these two will do. Okay.
Mm. Mm.
So for this member, what are the two sides?
For E, two sides. So
For this one, for
E
this
and F.
member, E and F.
E and F.
Now, so look at the point here. There it is E, it is F. Okay.
Mm. Mm.
So find the distance here, then multiply. Need to multiply. So that much kilonewton is the force.
Force.
Okay.
Yeah.
Uh, Not EB. What is the member? That is AD.
EB.
Okay. So the force is, uh, sorry, that is EF actually. Now tell me if it is in compression or tension.
Uh, when we're looking from E to F, this side is
E to F means here it is this
this
direction.
side. Yeah.
Fine.
Yeah.
Now E to F. If you look, what is the right? What is the right side? Right hand side?
A.
This one or this one? This
A.
one. A end. So here it
Mm.
will be this one.
Okay.
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 So that means here it will be like this. So that means this member is in
Tension.
uh, no, this one is at
Mm.
intention. No?
Okay. Compression.
That is compression. So actually compression is when forces are towards the nodes.
Okay.
Towards the node, these are nodes, right?
Yeah.
So towards the node means compression
Compression.
and away
Away
from the
from
node,
the node is tension.
tension. So okay, this one now we'll do for a for at one that is inside. So between G and H, suppose.
Okay.
So not between G and H, for this member actually. That is EC member.
Easy
Okay.
member from G to H.
From G to H or H to G, whatever.
Mm.
So that is the length. So you can measure this one and you can
Okay.
put the value here.
Okay.
So that is your EC member. Fine.
Mm. Yeah.
Now tell me if it is in compression or tension.
From G to H in this direction. Compression.
Yeah. Mm,
Okay.
why? This is the direction. That means from the node it is
Mm. Away from the node.
away from the node. So that will be in tension.
Away from the node. Okay.
Was this one you are getting right? That line, that
Mm.
direction.
Mm. Only in the right hand. First, we have to check from
Yeah,
G to H which arrow, and in the right hand side, we have to put that same
yeah,
arrow.
yeah. That arrow you have to put in the right hand side only.
Okay.
Okay. So
Okay.
in this way, you can find out all the forces and if it is in compression and tension.
Mm.
But
Okay.
in this question, they have asked little bit the different that also state whether each member is a strut or a tie.
Mm.
So what is the definition of strut and tie?
Mm.
So strut means
Mm.
the member is in compression
Okay.
and obviously tie will be the opposite one. So tie is when the
Member in
member is in
tension.
tension.
Okay.
You can remember this one by just simple take. There's tie T here, tension T here. That's
Okay.
it. Okay.
Yeah.
So that's it. So in this way you can find out forces here. Fine.
Mm. Yeah.
So that is the graphical method. Now, if we want to find out what is the forces at the using method of joint and method of section,
Mm.
so we'll discuss that.
Hello.
Okay.
Oh.
Hello. Yeah.
Oh.
So suppose we'll start with method of joint first.
What is Bose notation?
Mm,
Including use of Bose notation.
Gauss notation. Okay. So Gauss notation is this one actually. This notation means the note. If you mention some notation between the forces,
Mm.
okay. Since you are
Okay.
giving notation between the forces in capital letter, obviously, then it is known as Gauss notation.
Okay.
Okay. Actually, if you
Yeah.
look at this one, that is here we have the Gauss notation. These
Mm.
things. Okay.
Mm. Okay.
So we need to determine the magnitude and support reaction, also force in the members. Fine. So R1, R2, we have calculated. That is the what we can say. That is a universal method. That equilibrium, using equilibrium. Okay. If you use method of joint or method of section or graphical, whatever, the equilibrium reactions you need to find in this way. Okay.
Yeah.
Now to find out the forces on the members. So if we look from here, so first of all, we'll try method of joints. In the method of joints, what we need to check? We need to check at the nodes only. Okay. So just think about the first node, this one. So for this one, what are the forces? One reaction is there, that is our R1. We know the value. Fine.
Yeah.
And what are the other forces due to this member and this member? Right?
Yeah.
Actually, we don't know the direction also. Direction as well as magnitude. We don't know anything. But actually, what we can say that means direction means we don't know if it is on right side or left side. But we know that for the member AE, it is horizontal. Fine.
Yeah.
So suppose we are assuming that is in this direction.
Okay.
And for this one, that one will be parallel to this line. So it will be this direction, and angle is here, that is 60 degrees. Okay. Not this one. Suppose we are taking away. Okay, that is our assumption that we are taking away. So we can what we can call that, that is suppose force for the member AE. Suppose we are mentioning this one as D member our. Okay.
Okay.
So this is our member. So suppose this is our F of D. And this one is our F of E. Okay.
Okay.
So if we zoom in this one, so here it is 2.75. This side we have F of D, and here it is F of E, and here angle is 60 degree, right?
Yeah.
Now for this one, you can use your summation of Fx is equal to 0 and summation of Fy is equal to 0. Fine.
Okay. Yeah.
You know this angle, so you can take the components of Fe. Fine.
Yeah.
So two equation and two unknown. So obviously you will get the two values Fe and Fd. Okay.
Yeah.
After finding this value, suppose here Fe you are getting positive. That means whatever direction we have taken, actually this will be negative. So suppose you are getting Fe negative. That means whatever we have assumed, we need to
Is
draw in the opposite
in the
direction of that.
opposite direction. Yeah.
So that is towards this node, this node, right?
Yeah.
So that means this member is in compression. Towards the node, that means compression, right?
Yeah.
So for this member, that is in compression. Fine.
Yeah.
And when you can check that as your Fe is negative, and Fe, if you write the equation of summation of Fx, that will be Fd plus Fe cos 60 degree by cos 60 degree, that is equal to 0. And actually Fe sine 60 degree, that is 2.75. minus 2.75. So from here you can calculate your FE, right?
Yeah.
And if you put your FE here, you will get your FT as positive. Positive means whatever we have assumed that is fine.
Mm.
And if this is the direction ultimately, that means away from the joint.
Mm.
That means this member is in tension.
Okay.
And this one ultimately we got in the compression. Fine.
Okay. Yeah.
So using this thing, you can yes, you can find out the forces for all these members. If you suppose you check for the point E, okay.
Mm. Mm.
So for E, now you know this FD.
Yeah.
Uh, wait, okay. We'll check for this one and we'll discuss why we can't take this one right now. You know FD, right?
Yeah.
Now, if you look at this point, and what is the direction actually for FD? From here, it is this side.
Mm.
As we, after calculation, we check that is away from the node. So
Mm.
obviously, from this point also, it will be away from the node.
Okay.
So that is the direction of FD.
Mm.
1 kilonewton force is there downward,
Mm.
right?
Yeah.
For member C, suppose that is our FC.
Yeah.
Similarly, for this one, suppose that is our member H.
Mm.
So for this one, so that is our FH. And suppose this is our member F. This is the direction FF. Fine.
Yeah.
Now, when you will write the equilibrium equation at this point,
Mm.
so you have two equation actually,
Mm.
right?
Yeah.
But you have how many unknowns? FD you know that you have
Yeah.
checked from point A,
Yeah.
but these three are unknown.
Yeah. So we can't find out.
We can't find out. So actually, we will check for another point. Suppose if we do for this point, so
Mm.
we know that 3.25 Newton force. So
Mm.
we can find out the forces in these two members in the same way as we have checked for these two members.
Okay.
Okay. So
Okay.
from here, from this point, if we can find out the forces at these two members.
Mm.
So now no. Now if you check for point T, this one known, this one known. Here one
Mm.
Newton is given. So you can find out for these two members.
Mm. Okay.
Means actually you need two unknown only because you have two equation.
Okay.
Okay. So that is the
Okay.
condition. For a point, you need to check how many unknowns are there. If it is
Mm.
more than two, then you can do this one for at least for that time. If first
Mm.
of all you need to check at the points where we have two or one unknown.
Mm.
Okay.
Okay.
Okay. So at this one, if you do, these two members are done. So 1, 2, 3, 4, 5, 6 done. Now for this one, take this point D or C, whatever. If you take this one, 2 unknown, this one is given, so you can find out for A. Fine.
Mm.
So that is
Okay.
the method of joint. So method of joint means you need to write the equilibrium equations at the nodes.
Notes. Mm.
Okay.
Yeah.
Now let us check for method of
Method of
section.
section.
So for that, just 1 minute. Hello.
Hello.
Just 1 minute.
Okay. Okay.
হ্যালো হ্যাঁ হ্যাঁ বলছি ফোন করছি হ্যাঁ পরে করছি তবে বুঝতে হ্যাঁ এখন পড়াচ্ছি ঠিক আছে হ্যাঁ hello.
Yeah.
Okay, so method of section means, so
Mm.
just let us draw this one roughly. At these 2 points, we have the reaction here 1 kilonewton, here 2, and here 3. Fine.
Mm. Yeah.
And these two values actually we got as 2.75 and 3.25.
Mm.
Okay. As I have already told you that to find out the reactions, you need to use that equilibrium equation for the whole truss. Fine.
Yeah. Yeah.
Now, using method of section, what we will find out that what are the forces in these members actually.
Mm.
Okay. So first of all, what we'll do in the method of section, we need to take a section by random cutting.
Mm.
But actually, there the main thing is just check if the line of cut passes through two unknown member.
Okay.
So that means what? So suppose we are assuming that we will cut a section from here.
Mm.
Okay.
Mm.
So if we cut this section, so the cut line is going through these two members
Yeah.
and these two members. So we have two unknown members only, right? So we can
Mm.
cut from this point.
Okay.
Okay. So if we cut from this section, so if we
Mm.
draw this in, so here it is. We have cut from here. So suppose these two.
Mm.
Okay.
Mm. Mm.
Now for this one, actually, what we have already solved.
Mm.
Suppose that is F1, that is F2. So using that formula, summation of Fx equal to 0, summation of F is equal to 0. You find out F1 and F2. Fine.
Yeah.
And again, that thing that if for this section, if one is you are getting positive, that means that is away. So the member is in tension. Fine.
Mm. Yeah.
Okay. So these two things is done. Now what we will do, we
Mm.
will cut from another section and we need to check if the line of cut is passing through only two unknown member.
Okay.
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 So if we cut from here,
Mm. It is passing through three unknown numbers.
no. Actually, this one is unknown. This one is unknown. This one is so you already find out from cutting here.
Okay. Fine.
Okay. So this one is known now.
Okay.
So these two are the unknowns, right?
Mm. Yeah.
So let us draw the section after after doing the cutting operation.
Mm.
So here it is like this. Here we have 2.75 kilonewton. This
Mm.
one, so that is our F1 that we know actually.
Mm.
Okay.
Mm.
And at this point, we have 2 kilonewton.
Mm.
This side we have a cut section. So suppose that is now that is our F3, suppose, and
Okay.
that is our cut section. So that is like this.
Mm.
Okay.
Okay.
So actually you need to take this section only.
Mm.
Okay.
Yeah.
Now for this one, you need to apply summation of fx equal to 0 and summation of fy equal to 0.
Mm.
Okay.
Yeah.
Mm. And obviously the cut line I have drawn in this way, but that should be a line. Okay, that is not like a curve. Like you can draw in this way.
Mm.
Okay.
Okay.
Actually, that will be just check the line cut passes through, not two, that will be three actually. Why? Because you can also apply moment about any point zero.
Okay.
So we have three equations. So if you have check for three unknown, that is fine.
Mm.
Okay.
Okay.
Okay. And actually, it's not like every time you need to cut in the vertical direction. You can also cut horizontally or at any angle also. This angle. That is also fine.
Mm.
Okay.
Yeah.
So actually, instead of this line, after
Mm.
cutting from here, these two we know, right?
Yeah.
Just do what? Cut from this section. Okay.
Mm.
So
Okay.
if we cut from here, so you can take any one, the upper one or lower one,
Mm.
anything. Okay.
Mm.
So if you take the lower one, here you have 2.75 kilonewton force.
Okay.
That is F2 that we have already found out, right?
Mm. Yeah.
Now at point E, here we have 1 kilonewton force downward.
Mm.
Now we have cut from here. So these two, fine.
Yeah.
Suppose that is our F5 and F6. And this one, that is our F7, suppose.
Okay.
Okay. Now here actually you can apply, this one is known. So if we
Mm.
apply summation of F is equal to 0, summation of F is equal to 0, and moment at any point. Suppose if you find out moment at this point, moment at A that is equal to 0. Fine. So
Mm.
summation of X means what? You need to write the horizontal component of these four forces. Then you can write this equation. Fine. That means first of all you need to write the component of these forces. Okay.
Mm. Okay.
Then you can do summation of F is equal to 0 also.
Mm.
Then you can find out moment from this point. So for that, that 1 kilonewton into this length, then the vertical component of these forces, because horizontals are passing through this point, fine.
Okay.
Like if you take the suppose horizontal component of F6, that is the horizontal one.
Mm.
So that is passing through point A. So moment about that thing is 0. So you need to take the vertical component into this length.
Yeah.
Okay, and you need to check obviously that uh, directions also for
Mm.
sine. So using
Okay.
these three equations, you can find out these three values, F5, F6, and F7.
Mm.
Fine.
Yeah.
So 1, 2, 3, 4, 5. Done.
Mm.
Now these two sections are left.
Okay.
That means these two members. So cut from here.
Okay.
From this end, you can also draw, or you can draw from this end also. if you draw from this end, it is like here it is the force, here is the force, that was this section, and here is the force. Here we have 3.25, here it is 3. And this one we have just calculated. That is our F6 actually. So what are the unknowns? That is F8 and F9, suppose. These two are unknown.
Okay.
Fine. Use those summation. So two equations means you can just apply any equations, any two equation between these two.
Okay.
Okay.
Yeah.
That that is our method of section.
Okay.
Okay. So that means what you can do, we have discussed all the three methods. So you solve using these three methods. Okay.
Okay.
And then just check if the answer solutions is with you. That is fine. You can check with that. Otherwise, you can check if you are getting same values for the members using these three methods or not. Okay.
Yeah.
Do checking. Then if you are getting any doubts after that also, then we can discuss that later.
Okay.
Okay. And in the next class also, we will discuss these questions. And if you have another question, that also we can discuss. Okay.
Okay. Fine.
Okay, fine. I am shared both the files with you. Okay.
Okay. Yeah. Okay.
Thank you.
Thank you.